Good afternoon. Welcome to today's webinar. We really appreciate you joining us. Today, we're going to be talking about 6 reasons why your educational center needs a KIBO robot. So during this hour, we'll share a bit about what KIBO is, the strong research foundation behind KIBO, the benefits of introducing engineering, robotics, and coding in early childhood education across all kinds of educational settings. So we're excited to share kind of this diversity of perspectives and to welcome you. We see people have joined already who represent museums, childcare centers, library systems. So we're excited to share some of the benefits of using a robot like KIBO across all of these different contexts. My name is Jason Innes. I'm the Director of Curriculum and Training here at KinderLab. And I'll be on the webinar if any questions come up about curriculum, professional development, or the research foundation that I could share more perspectives on. But actually our main presenter today is going to be Jeff Miller, who you can also see. Jeff is KinderLab's account executive, so he specializes in helping schools, districts, museums, childcare centers figure out the best ways to bring KIBO in to serve their students. So Jeff is going to be running the show today, and I'm looking forward to turning it over to him. But before I do, I'll just share one little piece of housekeeping. The webinar is being recorded today, so after the webinar, you'll receive a link, and you're welcome to share that with your colleagues, other folks at your organization who might not have been able to join, or really just anyone you think might be interested. And then during the webinar, we'll have time at the end for questions that you may have. So in your GoToWebinar control panel or user interface, you have a questions button, and you can use that to send any questions in, and I'll collect those during the webinar, and then I'll pass them along to Jeff, who can address them at the end of the hour. Okay, so thank you again for joining us, and I'm gonna turn it over to Jeff Miller. So thanks, Jeff.
Thank you, Jason. And I just want to reiterate, we have over 160 hours of curriculum that Jason created. So please feel free, during the question and answer session, if you have curriculum-based questions, Jason is an extraordinarily valuable resource for us to use, and feel free to ask questions either of myself or of Jason. So Jason, thank you for the introduction. And my 6 reasons that educational centers need a KIBO robot are right here. 1, 2, 3, 4, 5, 6. Look at those kiddos. So I'm here to talk about KIBO today, and that is our robotic kit that allows 4-year-old kids to imagine and build and program and decorate their own robot, and then to bring it to life. Our goal here at KinderLab Robotics is universal STEAM literacy. We want to be able to affect and change the world. We want to be able to do it in a way that's fun, that's educational, and that gets kids excited about coding before sports and gender and peer pressure get in the way. And whether you're from a school or a library or a museum, what a wonderful opportunity to expose the kiddos to this program. And we want to build those skills and confidence in our littles and get them started in STEAM thinking and collaboration. Do we want to make them all engineers? Absolutely not. Are they being exposed to technology at a young age in this society? Absolutely. Are they curious? Absolutely. So this program, this research-based program, will help them along that way and get them excited about coding. So why do we do it? The chart on the right is a demonstration of the more we invest at the younger the age, the higher return we're going to get on this investment, right? And the demand for STEAM education is growing. There are going to be increased STEAM requirements in the next 20 years for jobs. And if we don't get these kids started young, if we wait till they're in the 4th grade, our research shows that there's a 33% drop in interest, especially for the girls, right? And the other thing that we learned about teachers, whether you're librarians or preschool teachers, no one taught you how to code when you were a kid. So there's a certain amount of anxiety around them being able to feel comfortable teaching STEM. And this is a program that you'll find makes it easy and it gets them as excited as the kiddos. And what's the societal impact, right? We can reduce gender, racial, and economic inequalities of STEAM literacy. We can make our STEAM literate citizenry make better decisions and improve our economic competitiveness, and look at the jobs out there that are STEAM related that we can start to expose our children to at a young age. So our program, it's based on 20 years of research from Tufts University and elsewhere. The program is physical, it's tangible. Kids can relate to blocks, and there are no screens at this age. It's screen-free, and it's designed for them to open-endedly express in their play, to allow them to integrate these new concepts, these STEAM concepts that they're going to learn. And for teachers and programs, it's really easy to integrate into the curricula. And I'll get into that as we move forward. So here's what KIBO kind of looks like. We've got these wonderful sensors, a light bulb that will allow KIBO to elicit light, an ear that will allow KIBO to hear a clap, an eye that will allow KIBO to understand light versus dark, and a telescope that will show KIBO the difference between near and far. If we want KIBO to move, we have wheels, and the wheels have motors that attach to the platform. And the platform has a scanner embedded in it. And I'll get into what that scanner does for us. So the kids will have to understand the relationship of these sensors and of these blocks, which tell KIBO what they want KIBO to do. And these blocks have words on them for kids who can read. They have symbols on them for kids who are aspiring readers. They have colors. So if we want these to program movement, we have a forward and a backward and a spin and a shake and a turn left and a turn right. So if we want KIBO to move, we can code and create these programs that allow KIBO to move. We have a beginning, and I like to draw the analogy. It's coding is like telling a story, right? And every story starts with a beginning. It has chapters, and each block represents a chapter in our story that we're telling to our robot. And it has an end. And the symbols, green means go, red means stop. And then we have blocks that can elicit red, white, and blue. We have blocks that can make sounds. We can have KIBO beep or sing. And we have blocks that allow KIBO to hear, in this case, wait for a clap. So they do have to understand how the blocks connect with the sensors in order to make KIBO do what they want, that relationship. And then once we're finished with our basic commands, we can get into some advanced stuff. We have the ability to repeat movements. So if we want to move forward 2, 3, 4, or what kids love, forever, we can do that with our repeat command. Or we have if-then statements, right? If light, then do something, or if near, then do something. So these are the kinds of things that kids and 4-year-olds are doing this. And our research and data show that they are more than capable of doing these types of things. So if you're telling us, if you want KIBO to move forward, one, you would go begin, you tether the forward block, and you put the forward next to the begin block, and then you tether that with the end block. Begin, forward, end, and KIBO moves forward one space. So that's kind of how it all works. And over the years, we incorporated in 2013, we've started to add on to this platform and build extensions. So we have the ability to express ourselves and have the children be able to tell people what KIBO is or what it's doing. We also learned that there are a lot of Legos in classrooms and libraries and museums. And so one of our platforms allows you to build Lego structures with your KIBO. And a very popular add-on is this module that allows us to record our voice. So we have a microphone sensor and we have blocks, 3 different blocks. They represent shapes, triangle, circle, and square. And you've got your triangle, circle, and square, and you can record an animal sound, your own voice, Spanish, a different language. So there are a plethora of opportunities using sound with KIBO that can incorporate this into the STEAM experience for the kiddos. We have the ability to write letters or shapes. And so we have this shield looking that has arms off of it that we can put markers in, and we can daisy chain the markers, and we can put them in experiment, putting them in different places on the back plane of KIBO. And the free throw, we're actually introducing physics with a robotic arm and a special block called throw, and that allows kids to program the KIBO to throw a ping pong ball. It comes with an elastic band and a ping pong ball, and we're looking at arc and trajectory and tension, and there's all kinds of things that you can do with our free throw add-on to KIBO. And one of our most recent additions that Jason created for us is the KIBO Advanced Coding Extension Kit. It allows you to do things like subroutines, where you take a whole command structure of blocks that we saw earlier, and you program that whole structure into one of the blocks. We have KIBO moving randomly, like spinning a die. So you don't know if KIBO is going to move 1, 2, 3, 4, 5, or 6 times. And we have other block capabilities as well. If then statements, if not statements. So that's, and that brings us past the pre-K kindergarten grade levels into 1st and 2nd grade and beyond. So a little bit about us. Our founder, Dr. Marina Bears, she's our Chief Science Officer. She's also so passionate about research. She's an author, and she's got a wonderful lab at Tufts where she oversees her research there. And there is her website, ase.tufts.edu/devtech. And she also has the Elliott Pearson preschool right in her backyard. So she has plenty of children to work with to continue in this development. And Dr. Bears garnered $1 million from the National Science Foundation in 2013, but she realized that she's passionate about research. She's not passionate about running a company. And so she brought in a gentleman by the name of Mitch Rosenberg, and he is our CEO, and he's got backgrounds in small startup companies, Kiva Systems, which does robotics in warehouses, and PictureTell, which did video conferencing, and Rethink Robotics. So he's got the qualifications, the MIT undergrad degree and the BU MBA, and he has been our leader since 2013 when we first started. So Dr. Bears' research is all about Piaget and this constructivism approach to learning, right? Kids learn by doing, right? And the instructor is not lecturing, right? The instructor is facilitating. And this is the core of the project-based approach that KIBO is all about. Kids are not sitting in a computer lab consuming. They're working together to produce and to create and to imagine. She got her PhD at MIT, and she took what Seymour Papert had, which he was the inventor of Logo, which was really the first educational coding language. And he created a machine turtle and had the kids draw with it. And he took constructivism and coded it constructionism. And the main points here, again, children learn best when they're working with a tangible product. And in this case, it was the turtle. So she took all of this, and she has, along with 5 books that she's written, she's really brought this to our early childhood children. She's also created a free app that you can use on your iPhone or your iPad called Scratch Junior. It's block coding. And if you work with and go to her website at DevTech, she's got all the research behind KIBO and behind Scratch Junior. It's a great resource for you to take advantage of. So these are 3 of my favorite books. Dr. Bears draws the analogy with coding. She calls it, she wants kids to embrace it as if it were a playground, right? When we're first born, our parents put us in a playpen, right? Very safe, but not a real good opportunity to learn much about anything. But I'll tell you what, when kids get to the playground and start experiencing apparatus and other kids, that's where the learning begins, right? And the parents are still on the park bench, maybe 15 yards away, and it's still secure. And so she wants that whole idea of coding becoming a child's playground. And this book, Designing Digital Experiences for Positive Youth Development, is all about how do you bring technology into the classroom, right? And so when you incorporate a new technology into a social, emotional, socio-cultural context, you've got these cherished assets, right? You want the child, especially with KIBO, for example, to care about their robot and to make a connection with it and to work on it making a contribution to society. And they're building competence and confidence and creating character as they work with that robot. And the new technology represents the blade here. And these are the cherished behaviors that are so important as kids need to communicate and work together and collaborate and build a sense of community. They need to create content and be creative and choose to be a contributing member. And then how do we take those wonderful behaviors and incorporate them in our classroom? Are we using tech circles or final projects? Are we learning about the engineering design process? Are we having an open house where we can present our findings to our teachers and our parents and others? And that's what that book, Designing Digital Experiences for Positive Youth Development, is about. And the huge skills, the most important skills that we're teaching these kids, we call them computational thinking skills. And these are the foundations of math and of literacy and of writing, right? And so with our coding, we're learning about algorithms. We're learning about that things have to be done in a logical order. And modularity is huge because it's the first time they're taking a large project and they're breaking it up into chunks. And this is the cornerstone of learning how to follow instructions and learning how to write. And with control structures, we're creating patterns. And if we do this, what's the effect and what's it going to come out as? And the representation using symbols, right? Symbols are, again, the foundation of learning how to write. A lot of kids think that technology is magic. I like to use the analogy when a 4-year-old sticks their arm in an elevator that's closing and it flashes open, and you ask them, why did that happen? 99% will say it's magic. We want them to understand that robotics is not magic. Humans did it, and that's important for them to know. We're teaching them about the engineering design process. We're building grit. We're allowing them to solve problems so many times, right? We teach kids that when you get something wrong, that's bad. For an engineer, that's an opportunity to improve and to get better. And we want them to check their work and to build grit and to improve. There's no right or wrong. We want to continue to strive to get better. So these are the important 21st century learning skills that this program models itself after: critical thinking and creativity, collaboration, and communication. And our research shows that by the end of kindergarten, we see over 60% improvement in sequencing skills. And look at this, girls, 85%. When they're asked if they'd enjoy being an engineer, say yes. And we are in public schools, we're in private schools, we are in libraries, we are in museums and after-school programs and camps. We are in 61 countries. We are in all 50 states. And we've got probably just over 15,000 robots in the hands of about 5,000 different school districts and agencies using the program. So why coding for 4-year-olds? Right, I mentioned this earlier. We want them actively producing rather than passively consuming. We want to build that confidence. We want them comfortable with technology and engineering, and we want them to make coding their playground. And as Piaget and Papert said, they're learning by moving and doing and experimenting and playing and collaborating. It's screen-free, it's reinforced by kids moving, and we know that 4-year-olds want to move, and it's tangible. The underbelly, this is what KIBO looks like, right? It's not a cell phone where we're hiding it. We want them, we're intentionally transparent. We want them to see that there are batteries and cables. We want them to see that there are circuit boards and processing chips. There's a speaker. These are what our motors look like, and ribbon cables, and humans did this. And we want them to understand, again, that it's not magic. And we're teaching kids science and mathematics. We're not teaching them as much about technology, which this is, screen-free technology, and this whole idea of the engineering design process. We want kids in groups asking questions and imagining solutions, making plans, and then creating, and then testing and failing and improving. And then at the end, we want them sharing and learning and building confidence and self-esteem. And then we add a very exciting component which differentiates this program from all others from this age group. And that's the ability to integrate art and classroom supplies to make the robot what they want it to be, right? That picture at the beginning with the sensors and the wheels, that was not a robot. That's the platform. It's what they build on our stages that we provide that makes this program fun for the kids, easy to integrate with any curriculum, whether it's math or science or social studies or English or Spanish, languages, language arts, anything. It becomes an extension of what they're learning in the classroom. So we want them to be, we want this to be kinesthetic for them, and we're introducing coding and sequencing and building and technology and sensors and variables. We want them, problem solving and collaborating together, and we want to make this easy for the teachers. No Wi-Fi, no computers. It's a standalone robot, and we want 2 or 3 kids at any given time working with one robot. It's not meant to be a 1-to-1 ratio. So here's the magic, right? What can KIBO become? And these are examples of what kids are doing today with our program. First, I wanted to show you what our model computer lab looks like. It's not a row of computers. It's not rows of kids sitting consuming. No, our model is kids creating and singing and dancing. So this code that these kids created, begin, forward, backward, forward, shake, spin, beep, end. Well, let's hear what the kids have to say about this.
You put your robot in, you put your robot out, you put your robot in, and you do the hokey pokey and you turn yourself around. That's what it's all about.
That's our 21st century computer lab. At this age, we want them moving and singing. They couldn't wait to press that button again. So this is an interesting curricula that you can download from Marina's website at DevTech. And it's really introducing social studies to the kids, right? So the context behind this is you're going to study a country and learn about the culture of that country. And the assignment of bringing KIBO into this is you're going to create a dancer from that country. And you're going to dress the dancer in the dress of that country, right? So what is the coding piece here? The dance, right? They're going to create a dance synonymous with the country. So on Monday, you're learning about social studies and cultural dancing and different cultures. On Tuesday, we're learning about our community. So KIBO is no longer a dancer, right? The people there, they're the tongue depressors, right? We've got the feathers as the clothing. We've got our nice happy lights on our car. And Jason has created some curricula that you can download at no charge from our website. It's a curriculum of floor maps. And in this case, we've created a floor map of our community, right? And the assignment, the coding piece is let's get our car from home to school, right? And we've got our traffic signs and our traffic lights and everything in our town. And so KIBO on Tuesday is a car. On Wednesday, we're learning about nouns. So let's create a fictional town called Nountown. And let's send KIBO down to Nountown to learn about all the nouns in our town. This is a school district in Atlanta that did this, Cobb County, one of the elementary schools there. Science, well, we're learning about butterflies. So why not have KIBO become a butterfly? and let's create KIBO's habitats and negotiate and learn about how a butterfly needs to live to exist in its habitat. So we're learning about that, and we're extending the learning by introducing coding to that lesson, right? So we're not going into a corner and putting a bunch of blocks together to make a stationary robot move and saying, wow, we've done coding. No, that's not what KIBO is about. It's cross-curricular, and it allows us to integrate it easily into our curriculum. This guy made KIBO a cave explorer, and he created a maze of boxes, and he's using that light sensor to navigate, to have KIBO navigate its way through the caves. Math, no problem. Measurement, estimation. Today, KIBO's a bowling ball, and we navigate its way down either a straight lane or a lane that has obstacles, and we see how many plastic bottles or plastic pins KIBO can knock down. Contextualization. Any story that we read, any story, the central character becomes KIBO. One of our favorites is The Very Hungry Caterpillar. We read the story to the kids, and then we have a project, and KIBO becomes the caterpillar, the food sources, and then you can have KIBO move forward and shake over the food to emulate its eating the food. These young children read a story called Going on a Bear Hunt. And so KIBO had to go through a snowstorm and through a cave and get under the chair, and then the bear roared, and so they made KIBO turn around and run away because their KIBO was afraid of bears. So KIBO can be an artist, it can be a dog or a horse or a dancer. It's whatever these kids imagine, whatever you imagine, and it lets them build and decorate and code those imagined creations. So assembly is pretty easy. So I'm going to show you this quick video. You're basically putting your motor on your wheel if you want KIBO to move, and you're attaching the wheel to the side of the side of the back plane. You're putting the sensors in that you need. In this case, we're just putting them all in. And then you remember, we're beginning with begin, ending with end, and this is a shake command, and then you're scanning the blocks. And you press a button, that triangle there, and that's how KIBO shakes. And then you can mount a platform that either spins or remains stable, and then you decorate the platform. In this case, it's a holiday motif, and you've got your snowmen or your pumpkins coming up for Halloween, and it's as simple as doing that. So Jason, our special sauce at KinderLab Robotics, his philosophy with the curriculum that he's developed involves three important areas, right? The programming piece of it, which we call computational thinking, the engineering design process, which is the actual building of the robot, and then the integration component, the curriculum theme. All of our curriculum philosophy remains consistent with these important themes. And it starts with our Growing with KIBO, which is a pre-K to second grade curriculum that has 3 different levels: beginning, intermediate, and advanced. It has 60 hours of instruction. These lesson plans are simple and clear, and you don't have to be a technical integrator to be able to deliver it. And these are designed importantly for whole class instruction. So probably more in line with first and second grade, because the littles tend to need to be in smaller groups. But to kindergarten, we've had some success with that. Another guide for the pre-Ks and the littles is the KIBO curriculum guide, 20 to 40 hours of instruction. The lessons are about 1 hour to 2 hours. And you're learning about the different parts of the robot and how, and we've got lessons and activities around that. We start with just engineering and making a simple structure and dropping it from our ankles. And then we start learning more about some of the repeats and the sensors and the what ifs and all the commands. But it always ends up in a project, right? This project-based learning program that we have. For pre-K and their activity centers, we highly recommend the activities center guidebook. Generally, you have 2 to 3 kids in an activity center and 2 robots, so maybe 4 to 6 kids. And there's all kinds of things. I love this. The snow plow with the cotton balls. I mean, that's great. We've got bowling and light and shadow and dance parties and shape searches. Kids have an affinity with pets, storylines, flowers, number lines. There's a lot of really exciting activities here. One of the complementary curriculums that you can download, or curricula that you can download, is the KIBO Zoo. And kids literally create their own animals, and then they have a parade, and they parade around the zoo with their animals. And we also have a complimentary 25-minute video that supports this curriculum. And it's all available on our website. The floor maps guide, which I suggested earlier, we've got the community floor map, but also several others that you can use to incorporate KIBO into the classroom or into a project if kids are coming to the library or the museum. And the advanced coding blocks that I showed you also has a dedicated curricula that is engaging and complements that product. And for each of those sensors, whether it's an expression sign or the Lego add-on or the audio sensor or the drawing, we have additional books with additional lessons and activities that will allow you to benefit and use those products with fidelity, right? And this summer, we've been nimble, and with the epidemic, we have put together an amazing program similar to a library where you can check out KIBO from school and bring it home. And we're talking about intergenerational engagement and parent engagement and using the program at home and using video conferencing or Zoom conferencing to bring a group of kids together that have them at home to walk them through a program. And that's called Connecting with KIBO. And we've got, for kids at home or homeschoolers, we've got using KIBO at home. So there's wonderful blended learning guidebooks and curriculum design for those kids. And additional materials, whether it's posters or assessment workbooks. This one I really like. These are large mock-up cards of the individual blocks, and each one has a barcode on them. So if kids are having trouble scanning, especially the littles, well, instead of scanning the blocks, you can lay the cards out on the carpet and they can scan the larger cards. And if you're introducing these block concepts to a large classroom, you've got these large mock-ups that all the class and all the children can see. I mentioned contextualization before. Anything that they read, the central character can become KIBO. So I wanted to show you this. This is one of my favorite curricula that we have, and what schools, this happened to be a private school, they are using KIBO to reenact the Iditarod race. And I want to share that with you and have you see how KIBO can be incorporated in this way.
JCDS's Iditarod is a recreation of the Alaskan Iditarod, an annual dog sled race that takes place every March. The Iditarod commemorates the 1925 rescue mission that carried diphtheria serum across Alaska by sled dog relay to the sick children in Nome.
I like to use the Iditarod as sort of an overarching theme. It is project-based learning, so everything else that I teach involves the Iditarod. So for example, math is incorporated in terms of either story problems, how many dogs were dropped, or you can do it with measurement as well. Writing, we always write prompts about it. What was your favorite part of the Iditarod? How would you help the dogs? So it's different types of prompts. Reading, we have all kinds of read alouds. We work a lot on comprehension strategies during the lessons. And they're just really invested in it, which is why I love it. I think there's something about animals and kids that just the marriage of two creates this wonderful unit. And I don't need buy-in because it's already there.
The integrated Iditarod unit also includes a technology and engineering component. Thanks to Marina Bears, a JCDS parent, who is director of the DevTech Research Group at Tufts University, we have access to the leading edge of robotics tools for young learners and access to a classroom full of college students learning how to use technology in schools. Marina's class visited JCDS for 2 hands-on sessions. The college students were paired up with the first graders. During the first session, the teams worked together to build a robot and learn how to program it. During the second session, the college students and the first graders worked together to build and program a robotic dog sled that would make its way from one end of a poster board to the other to simulate traveling from one checkpoint to the next along the Iditarod route. The teams decorated their posters and their sleds, and they made sure to build a container on their sleds to hold the serum that they would carry in the relay. This part of the process involved a lot of trial and error. The students made an initial program and tried it out on the poster. Sometimes the sled ran off the trail, or a wheel fell off, or the serum container fell off. This part of the process requires multiple iterations of programming and testing. The students learn how to troubleshoot and how to persevere. They also learn to view something that doesn't work as a challenge, not a failure. It's an invitation to troubleshoot. That is where the learning happens. The JCDS Iditarod race itself is just one milestone in this learning. Our superficial goal is that the robotic sled follow the path from one poster to another and reach the end without incident. But the real Iditarod race does not run smoothly and without incident, and typically neither does ours. In the real Iditarod, dogs get tired, sleds break down, drivers make mistakes. In our Iditarod, wheels fall off, batteries fail, unforeseen events interfere. The real Iditarod race is a test of perseverance and problem solving, and so is ours. We cheer our students on and root for their robots to reach their destinations quickly and without incident. But we are also aware that this is not the important thing. As with much of life, the important things in our Iditarod race are the lessons about problem solving and perseverance that the students have learned along the way.
Excellent. So they really incorporated KIBO into all those different disciplines. And that's what I think and how I think KIBO should be utilized in any program that you incorporate. So our professional development, we can come out to a district or train a group of trainers and pass on our knowledge to you to pass on to your community. We can come out on site. We, especially during this time, are doing plenty of remote webinars. The idea of our training is not to make it cookie cutter, but to understand what you want to do, try to help you make recommendations on how to most effectively use it in your environment, and then work with you to create a program that meets your specific needs. And it's for us that, you know, it's most effective for you guys to take advantage of the training so that you can use the program. So as we move forward, right, we want to deepen our current curriculum and continue to develop and cultivate these ideas that folks out in the field who are using it, our research shows. We're going to broaden it and enhance the STEAM topics. We're going to create more accessibility, although we do have students who are deaf, who are autistic, who are blind that are using the program today. We want to continue to make it easier for all kids to be able to have access to our program. And we want to reduce the cost to make STEM literacy available to the broader population. So those are kind of our future goals. So those 6 reasons, right? We talked about the 6 reasons. KIBO's the only robot kit that can be built and programmed and decorated by kids as young as 4. It's tangible. We're taking abstract concepts and making them tangible. We're incorporating art into the program itself, which stimulates imagination, which makes it easier to integrate in any type of program you want to create for these kids. We're one step ahead of everybody else. There are a lot of products out there from 3rd grade up. We are a program, we're not a product. And Dr. Marina Bears is continuing to lead the way in worldwide STEM education. She is known as the authority in that area. We're the first mover, and I love the fact that at this age, they don't need a screen or a keyboard to use our program. So I am going to finish up with a brief demonstration of why John Gill Elementary School is using this, and what they see and how they see this benefits the kids.
They're ready for the kinds of beginning stages of computational thinking. They're ready to start solving problems, and in this kind of way. They're exposed to machines and computers pretty early on now. And so having them understand that they can have control over machines, sort of where we were really interested in teaching them about at an early age. It's not about the robot, it's about what the robot teaches you about computational thinking.
So the 2 foundational concepts that we teach kids when we teach them in making. So agency is the I can. It's the ability to do it, the ability to tackle problems, the keep it going when you make a mistake or when you can't do it. This is where kind of grit is enveloped in here. Character on top of that is what are you going to do with those powers that you have, right? You're going to help people. You're going to share. You're going to treat equipment with respect. You know, you're going to fix things that get broken. And there's another level above that, like once you get into the job sphere, like when you're interacting in a school setting, these are all very, you know, kid-centered skills, but as you grow, they grow with you. And so character in the real world is about making things that benefit people rather than exploiting them, you know, and agency is about, well, I have the power to change the ills I see in the world, right? I can create a foundation or get together with people and I can do it. Instead of just sitting back and waiting for other people to do it, you sort of being the consumers of culture and the, you know, participants in the system and you're part of the problem. You can step up and be part of the solution.
Agency, right? I have the power to change things in the world. Well, you will have the power to change and affect these kiddos with a program like this. So I think we have a few minutes for questions. Jason, I don't know if they've been streaming in at a furious rate, but we do have a few minutes. If you have questions, please email or text Jason through the chat utility, and we can try to answer some questions in the final few minutes that we have today.
Yeah, thank you, Jeff, and thanks for sharing all those perspectives about the best, sort of the ways that KIBO can come together to support, especially these sort of thinking strategies and these character attributes like persistence and grit that are so much a part of kind of the reason why we teach these things. We did have a question about recommendations for sort of explaining a little bit about how KIBO is sort of sold. You had mentioned that there's we recommend that it's not a one-to-one, but that small groups work with it. So would you mind talking a little bit about how, for example, a library or a museum might think about, as well as a childcare center, might think about like the number of KIBOs that's right for different groups and different applications?
Yeah, it's a great question. You know, typically we've got different flavors and configurations. We bundle them, and we have an activity center package that has 2 robots and can support up to 6 kids. We have a small classroom package that comes with 5 robots and can support 10 to 20 kids. And we have a large classroom package which comes with 10 robots and can support 20 to 30 kids. Now, these packages come with our curriculum, our professional development, assessment workbooks, and the robots. And depending on, we have different numbers of blocks that you can purchase along the classrooms. I think come in 18 or 21. And so you can kind of bundle it all together in a 2, 5, or 10 robot configuration. How are they used? So libraries, for example, you know, kids can come to a library, you can read a story, you can have KIBO extend the story in the library as an activity, so you can have all the classes come to the library. You know, museums, you can have after-school programs at the museums, you can have exhibits, you can outreach to the community with your KIBOs from the museum and bring it into the schools and expose these kids and their families to your museum. So there's a wide array of application for it.
Yeah, and I can share too, one of the sort of partner organizations that has been a long time KIBO user in this area is the Boston Museum of Science. And they actually have KIBO on sort of a coding cart that they bring out, so they don't have a permanent exhibition about coding, but when they're supporting coding education in the community, and really whenever they can, they bring a cart out with KIBO, and they have a guide who's there to sort of facilitate the children's experience. But the fact that KIBO is a manipulative, that's hands-on, screen-free, makes it a great sort of opportunity to draw in young children and sort of get them experimenting and playing with the materials. So KIBO, because of that screen-free aspect, is a great opportunity to kind of get museum visitors interested in coding, and that can work in a library setting as well. Great. Actually, the other question that we had was kind of related to that, which is you mentioned that Dr. Bears developed Scratch Junior as well. And I wonder if you can talk a little bit about sort of the advantages of introducing these concepts in a screen-free way over sort of what children might do on the screen. And I know that you addressed that a bit, so but if there's a little more you could share about the benefits of sort of the screen-free approach, that would be great.
Right, and it's a great question. Kids learn by doing, right? And the project-based, when they're working together and collaborating, and you can just see in this picture, you know, you've got the kids holding the robot, they're talking about it, they're excited about it. That's how our research shows that kids learn. It's great. I mean, both products are block-based coding, right? These are using tangible blocks, and the Scratch Junior is using computer-based blocks that are animated, or not animated, but they're computer-based. So it really, you know, stems toward the research and what Dr. Bears had gleaned from her studying Piaget and studying under Dr. Jason
Papert.
Seymour
Papert. Yeah.
Right. So that's the hands-on learning, and so both are effective if used properly, but this really gets to the kind of to the point of it with the hands-on and the project-based learning.
Mhm. Yeah, and I would say just sort of taking what you mentioned about the research, Dr. Bear, it's really with the younger end of our sort of age group that we're addressing here, the 4-year-olds, 5-year-olds, the kindergartners, where some of that developmental benefit is really the strongest. We have young children really learn abstract concepts only through kind of getting their hands on concrete manipulatives. Children at this age learn through concrete experience, and dragging icons around on a screen is still something that is a little bit too abstract for the younger end of this age group. So some of the research that Dr. Bears and her research team did directly compared young children's sort of development of computational thinking skills using both Scratch Junior and KIBO. And they found that for the younger end of that age group, the equivalent curriculum using KIBO, which was entirely screen-free, the children actually learned these progressed farther on tests of sequencing and of computational thinking than the kids who use Scratch Junior. So for the younger kids, there really is this strong research documented evidence showing that these manipulatives are a much more effective way to teach these abstract concepts.
Excellent.
So we had one, we had one last question come in, Jeff, which was about whether we can provide any guidance on sort of financing, grants, any ways to sort of pay for a program like this in sort of creative ways. So any guidance that you'd want to share there?
Yes, it's funny. I represented Dr. Bears' website, but if you go onto our website, kinderlabrobotics.com, we're constantly searching for grant options, and we're listing them in our on our website that will allow folks to visibility to see what's out there and to apply for that. So that's a great question, and there is money out there, and you should check our website out to see what those grants are and what the criteria behind them are. And the other thing that we have is we've already written the answers for you. So if you are looking for some information about what's important in the research and what's important about our program, we can work with you to send you some information that will allow you to complete your grant. So we're trying to find them for you, and we're also providing you the information to help you complete them.
Mm-hmm. Yep, thanks. And I don't know if you have a slide with the contact information or the website, but in case not, it's just kinderlabrobotics.com. And of course, you will receive an email after this webinar, as I mentioned, with a link to the recording, with a link to download a certificate of participation if you want to document the hour that you spent learning about these topics. And there will also be a link there to learn more about KIBO, to access that grant information from our website.
Yes, and also, Jason, if they want to contact me directly, my email address is jeff@kinderlabrobotics.com. And if you want to contact Jason directly, Jason's email is jason@kinderlabrobotics.com. So happy to hear from you guys, and feel free to connect if you have additional interest in the program.
Absolutely. Thank you, Jeff, and thank you everyone for participating in the webinar and taking the time to spend an hour with us to learn about this. And we do encourage you to reach out, get in touch. We would be happy to share more information about KIBO anytime. All right, so have a good afternoon, and thank you, Jeff.
Take care. Bye-bye.